Hello students, welcome to video lesson 8.1b. We're continuing our discussion in this section about relations, and in this video we're going to talk about a specific type of relation that's called a function. Okay, so we're going to define a function. We're going to talk about the different ways that we can determine if a given relation that we're looking at is or is not a function. So most of your homework is simply going to be yes or no, determining if something is or is not a function. All right, so first we have to talk about what a function is, though. A function is a specific type of relation. Okay, so we talked about relations in our last video about how they can be displayed as ordered pairs, right? We talked about relations just being pairs of numbers that are matched up together. We talked about domain and range being the input values and the output values of the relation, and they're always matched up or paired up together. So a function is just a specific type of relation. Okay, it's a relation that has to fit some criteria, and that criteria is that a function is a relation where each input value is paired with exactly one output value. Okay, so for every input value, for every value of the domain, or for every x value, I have exactly one y value. Okay, so that's the formal definition of a function. It's a relation where each input value, or each domain value, or each x value, I guess we could put that here, each x value, is paired with exactly one output value, which is also known as a y value. Okay, each x value gets exactly one y value. There's no x values that have multiple different y values, and there's none that don't have a y value. So depending on how the relation is being displayed to us, we have different strategies for determining if that relation is or is not a function. Okay, so we're going to go through three different strategies to look at. The first is for ordered pairs or tables. Okay, and this is sort of the first way that we looked at a relation. We had a table of values about the alligator lengths and things like that, how old they were and how long they were, so their age and their lengths. So for ordered pairs or tables, we just look for repeated x values. Okay, so the same x value showing up again with a different y value. Okay, and if there are repeated x values with a different y value, the relation is not a function. Okay, so this is a way that we can decide a certain relation is not a function if we see the same x value again, but with a different y value. That relation is not a function, right? Because that x value would have two different y values. For example, if in your relation you saw something like this, 2, 3 as one of your points, and then later on in the list you saw 2, 0 as one of your points, right? This is the same x value. X value is 2 in both of these cases, but that x value of 2 is being paired up with two separate y values. 2 is getting paired up with 3, and 2 is also getting paired up with 0. So because we have those two different y values for the same x value, it doesn't fit the definition of function, right? Because remember, a function, each x value has to be paired with exactly one y value, not two different y values like we see here with 3 and 0. Okay, so for ordered pairs or tables of values, we simply look at our x values and see, is there any repeated x values that have a different y value? If we are looking at a mapping diagram, remember those were these guys where we had like the big ovals, and we had a bunch of numbers in there, and then we had another oval over here, and then we were like drawing arrows from one side to the other side and stuff like this. Okay, so if we're looking at mapping diagrams, what we're looking for in a mapping diagram is we're looking for a value in the domain or in the input side, this left-hand side, this one right here, that has two separate arrows coming from it, because that indicates that that x value is being paired up with two different y values on the other side, right? Because there's one arrow going here, there's one arrow going here. So if we see any of our domain values in this left-hand oval that has two separate arrows coming off of it, then that is not a function. Okay, that relation is not a function. Again, it's a way that we determine if something is not a function. Okay, if you're looking at the mapping diagram and all of the domain values have just one arrow coming off of them, then that's fine. That is a function because we don't repeat any of those domain values with a second arrow coming off. There's just one arrow coming off of each x value, which is our definition for function. Okay, it's important to note that this is all about the domain. It's all about the x values in a mapping diagram. I don't care how many arrows there are going to the y values on the right. Okay, I don't care. All of the x values can be going to the same y value, and it could have 17 arrows going to it. That's fine, as long as all of the x values in the domain have just one arrow coming off of them. Okay, and you'll see an example of that in just a second. And then when we're looking at a graph of a relation, either a graph of a function, like a curve, like a line, or a bunch of points, we use something called the vertical line test. All right, and I have defined that here for us. The vertical line test involves drawing vertical lines through every point on the graph. Okay. Really what we're looking for is there a vertical line that I draw on that graph that goes through more than one point, that hits more than one point on the graph, okay? So just as a quick example, if I make myself a coordinate grid here and I put a bunch of dots, like there's a dot and there's a dot and here's a dot and over here's a dot and over here's a dot and over here's a dot and then like right here's a dot. Okay, so if I were to draw a vertical line through each of these points, I'm looking for a vertical line that hits more than one of the points on my graph, okay? So I just draw vertical lines through all of these points, and then I end up here, and that one I think hit 2 different points. Okay, so if any of those vertical lines hit more than one point, it's not a function, okay? Because that is the same x value, right? The same distance on our x-axis, but it's going to 2 separate y values. There's 2 different points at that same x value. So it does not fit the definition of a function. All right, so let's look at an example of each one of these, and we'll try to determine if they are or are not functions, okay? So first we'll look at just this set of ordered pairs here. Okay, this set of ordered pairs, there's 1, 2, 3, 4, 5 of them. 5 points. And we need to determine if this is a function. So what do we look for? Well, we look for repeated x values that have different y values. So I'm just going to start looking at each of my x values. Here's a 3, here's a -1, here's a 4, here's a 0, here's a -1. Did any of those repeat? Yep, the -1 repeated, so now I have to go back to those points. I have to go back to this one and see, are these actually exactly the same point, or do they have different y values with them? And in this case, they do have different y values, right? This one is a 2, this one is a -3. So I have the same x value, -1, with 2 different y values. So this is a big fat no. This is not a function, okay? No, not a function. And if we were asked to explain why, we would simply say because -1 is repeated as an x value, right? -1 shows up twice, something like that. If we look at this mapping diagram here, we have domain and range. I have 1, 2, 3, 4, 5, 6 points in the domain. I have 4 points in the range. So if I'm looking at a mapping diagram and trying to decide if that is a function, again, I'm looking in my domain area, right? I'm looking here in the domain in this particular oval, and I'm looking for numbers in the domain that have more than one arrow coming from them. So if I look at the number 1 here in the domain, how many arrows does that have coming off of it? Well, it has just 1, right? 1 goes to 4. What about the 2 in my domain? That goes to -5, and that's the only arrow. 3 goes to 4, and that's its only arrow. 5 goes to -5, and that's its only arrow. 7 goes to 2, and 8 goes to 6. So each of those domain numbers only has 1 arrow coming off of them. So I can say, yes, this one is a function. Okay, again, even though I have repeated y values here in the range, that doesn't matter. Okay, I'm only looking at the domain. Each of the domain numbers only has 1 arrow coming off of it. So it is a function. All right, and then our last example here is this graph. Okay, so I have this graph, I have a bunch of coordinate points, and I'm trying to determine, is this graph, is the relation shown here a function? And in order to do that, I'm going to draw vertical lines. Okay, so I'm going to take my line tool and I'm going to draw vertical lines. And I see a point here, and if I draw a vertical line through that point, whoopsies, that wasn't supposed to happen. If I draw vertical lines through this point, I think I only hit one point with that vertical line. I think I only hit one point with that vertical line. This one's actually on the y-axis, right? This point right here, so that one's fine. This one only hits one. This one only hits one. That one hits, that one hit 2 points, right? It hit up here and it hit down here. This vertical line hit more than 1 point. So that means that this x value, which I think is 1, 2, 3, 4, x equals 4, has x equals 4. Whoops. What am I doing here? X equals 4 has 2 y values, right? One is right here just below 0. The other one is up here at maybe, 1, 2, 3, 4, 5, like 6. Yeah. So x equals 4 goes to 2 different y values, right? It goes to y equals 6, and it goes to y equals, that's about 0. Okay, so because this vertical line hit in 2 different points, I have to say no. Okay, so when we do the vertical line test, just remember that it only takes one vertical line to ruin the whole thing, right? I know all of these only hit 1 point, and like if I did it here, that would only hit 1 point, and this would only hit 1 point. But because this one vertical line right here hit 2 different points, it's not a function. The whole thing gets thrown out, okay? It's not a function because that vertical line hit 2 different points. All right. So if you have questions about how we determine if a relation is a function in any of our examples or ways we can see relations displayed for us, please reach out to me and let me know. Otherwise, that's all I have for you right now, and we'll talk to you soon.